Sometimes the biggest ideas start small, like in a simple aquarium with a few tiny trees. The question they were trying to answer, though, it was huge. Can nature actually protect us from a tsunami? In this explainer, we're going to break down this really cool student experiment that pits a living wall against one of the planet's most powerful forces. Let's dive right in.
Okay, so first, let's just set the stage. Why does this even matter? Well, the source material puts it pretty bluntly. Tsunamis are highly dangerous ocean waves that can devastate coastal areas. We're not talking about a minor inconvenience here. This is about life, death, and the very survival of entire communities living by the sea.
And the damage, wow. It goes way beyond just that initial wave. We're talking about entire ecosystems getting wiped out, critical resources completely destroyed, and infrastructure just shattered. The ripple effects are absolutely enormous, which is exactly why finding better ways to protect our coasts is so urgent.
So when you're faced with a challenge that massive, what do? Well, a group of students asked a really smart question. Instead of just thinking about building bigger, stronger concrete walls, they thought, what if we could use a live-in natural barrier for protection?
And that brings us to the core idea of their whole experiment, their hypothesis. It's so simple and elegant. Can mangrove-like plants minimize the damage caused by a tsunami wave? I mean, what a great question. It's pitting a natural solution against a natural disaster.
So, how in the world do you test a force of nature like a tsunami? You can't just create one on demand, right? So they did the next best thing. They shrunk it. They cleverly recreated a whole coastline in a tiny, controlled setting, a simple aquarium.
Now, the real genius of this experiment is in how they structured it. To get a really clear answer, they set up 3 different situations. The first one had just the mangrove-like plants. The second had a mix of plants and rocks. And the third, just rocks. Comparing these 3 is the secret sauce to figuring out what's really making the difference.
And this just goes to show you, science can be super accessible. They built their own mini tsunami simulator with stuff like an aquarium, sand, and water. For their mangroves, they use something called Sabrina trees, which are perfect because their dense structure and root systems are a lot like a real coastal forest.
And their method was just classic solid science. They carefully built their tiny coastline, they positioned the trees just so, and then they used a wave maker to simulate the tsunami. The most important part, of course, was that last step. They ran the tests for all 3 setups and wrote down everything they saw.
All right, the moment of truth. They ran the tests. The tiny waves crashed against their tiny coastlines. So, what happened? What did these waves actually reveal?
Okay, so result number 1, the test with just the plants. It was actually really promising. That dense web of roots and branches acted like a natural break. It soaked up some of the wave's energy, and you could see it. The wave's height was noticeably reduced. The plants, all by themselves, were already making a difference.
But then they tried the second variable, the rocks combined with the trees. And this is where the effect got way more dramatic. You had the rocks providing this solid, heavy base, while the flexible plants helped dissipate the wave's energy. Together, they didn't just lower the wave's height, they slowed the whole thing down. A lot. This was a huge clue.
Now, this is why that third test was so important. When they ran it with only rocks, the effect was, well, pretty minimal. The waves barely changed at all, and that proved it. The rocks alone weren't the answer. The real magic was coming from the vegetation.
And honestly, this chart just tells the whole story in one picture. You can see it clear as day. The rocks by themselves? Barely any reduction. The plants by themselves? A decent, moderate reduction. But look at that third bar, the combination of plants and rocks. That gave them a significant reduction in the wave's power. That right there is the big takeaway.
So, what does a little experiment in an 80-centimeter aquarium mean for thousands of miles of real-world coastline? This is where we zoom out and look at the bigger picture, this whole idea of using nature as a coastal shield.
This experiment taps right into this powerful concept called natural barriers. It's all about finding sustainable solutions, using living things like mangrove forests to soften the blow from waves and prevent erosion. The core idea is just so smart. Work with nature, not against it.
And the students' own conclusion fits perfectly with this. As they put it, their findings underscore the ecological importance of cultivating such vegetation. Their small-scale test is pointing directly toward a huge-scale, sustainable solution.
And you know what I love about this? The students showed some real scientific integrity. They didn't pretend their experiment was perfect. They pointed out its limitations, saying that for even more accurate results, Future tests should use real mangrove plants of the right size and type. That's exactly how science is supposed to work.
And so we end up right back where we started, with a simple question and an aquarium. It just goes to show that sometimes the most powerful insights don't come from massive, expensive labs, but from simple curiosity. It really makes you wonder, right? Could more creative, small-scale experiments like this one hold the keys to some of our planet's biggest challenges? Thanks for tuning in.